Okay, this is problem 2b from section 2.2. In this problem we're given the transformation t from R3 to R2 by t of A1, A2, A3 equals 2A1, 3A2 minus A3 in the first component and A1 plus A3 in the second component. The problem is to find the matrix of T relative to the bases B and C, where B is the standard basis of R3 and C is the standard basis of R2. Okay, so this means that B is the basis E1 equals 1, 0, 0, E2 equals 0, 1, 0, and E3 equals the vector 0, 0, 1. Okay, the standard basis of R2 is the vector F1, which is 1, 0, and F2, which is 0, 1. Okay, we've written both our sets of vectors as rows since our transformation is given in row form. Okay, now to compute the matrix of a transformation, first of all we write down the vectors in B. Okay, so that's E1, E2, and E3. Then we take T of each vector, and then for these vectors we work out the coordinate vector relative to C. This is the matrix that we're after. This matrix here is the matrix of T relative to the bases B and C, and it's important that these three coordinate vectors are written as columns. So the first guy here is the first column, the second guy is the second column, and the third guy is the third column. Okay, so first of all we work out T of E1, which is T of 1, 0, 0. So in the formula up here we put A1 equal to 1, A2 equal to 0, and A3 equal to 0, and we obtain the vector 2, 1. Okay, now this is easy to write in terms of the standard basis. This is 2 times 1, 0, plus 1 times 0, 1. And that means the coordinate vector of T of E1 relative to C is 2 in the first component and 1 in the second component. Again, it's important that we write this coordinate vector as a vertical column. Okay, so the next one is T of E2, which is T of 0, 1, 0. Now this time we put A1 equals 0, A2 equals 1, and A3 equals 0, and we obtain the vector 3, 0. Which in terms of our standard basis is 3 times 1, 0, plus 0 times 0, 1. And that means the coordinate vector of this guy is the vector 3, 0, sorry. Okay, then T of E3 is T of 0, 0, 1. So now we put A1 equals 0, A2 equals 0, and A3 equals 1, and we obtain the vector minus 1, 1, which is minus 1 times our first basis vector plus 1 times the second. And that means the coordinate vector of T of E3 relative to C is the vector minus 1, 1. So therefore, the matrix of the transformation t relative to the bases b and c is obtained by putting these three columns into our matrix. So the first column is 2, 1, second column is 3, 0, and the last column is -1, 1, and that's the solution to the problem.